And then, based on these kind of basics, it's actually kind of difficult to understand just looking at one of the molecules, and then it is categorized into which group. So there are some flow charts to judge if these molecules are which category is each molecule. So here's one of the chart copied from the Atkins textbook, and let's check out one of them. For example, let's take the C2H. You have E and C2 and the sigma H population in this case. So if first you have to check if the molecule is linear or not. It's not. And do you have two or more the CN operation? And as you know, so only one C2 operation. And do you have CN operation? And yes. And then this is a little bit complicated, but select CN was highest N, and then the C2 perpendicular to CN, meaning that it's a situation like this one. So you have a molecular axis in the center here, and then perpendicular to this molecular axis, you have two C2 operation, right? So like this case. But in the case of C2H, there's no such the multiple C2 operations, so it's going to N. And then does it have a sigma H operation? And this one has yes, and then it's going to C2H, right? Like this, and you can now categorize each molecule to each of the group by using flowchart, and actually these flowcharts can be integrated into the software. And so what you have to do is now you have to draw the molecules in the software, and the software judge if based on this kind of chart the category can be decided. Okay. So based on the N value, so it's a symmetrical number, and also a number here, and also a different category of the operations each group has, and then there are many different type of symmetrical groups of the molecules. Okay, so now the key point is you can somehow categorize them molecule in each symmetrical group. So what kind of information you can obtain from the group theory? And here's some of the example here, and then you don't have to understand very strictly, but for one of the example here is polarizability of the molecules. And just by categorizing the molecule, and the molecules in the CN or CNV could have polarizability along the principal axis, right? So it's very intuitive. Like CN is a molecule, like molecular axis. For example, in the case of water case, right? So molecular axis is here, and CN is a C2 operation like this, right? And these molecules can have a polarizability in this direction, right? So it's very intuitive, because of course these molecules have some CN operation and CNV, and since this one has the symmetrical axis, and it can have, if the atoms are displaced in a non-symmetrical in the molecular, along the molecular axis, that gives the polarizability. So just by key point is just by categorizing the molecules, and if you they are categorized in a CN or CND, you can know that if the molecules are going to have the polarizability or not. And the other simple example just by categorizing is chirality. The chirality is, of course, one of the important the properties of molecules in medicine or some biology. And the molecules except SN group can have chirality. So whatever it is, SN is a highly symmetrical molecule, but once it is categorized into the SN group, that molecule cannot have chirality. So you can, just by categorizing the molecule, you could know the information of chirality. Okay. So with that, the first step of the group theory was we studied, and which is categorization of the molecules into the different group.